Hey, it's Emily, your favorite PodRocket producer. Did you know that LogRocket has a TikTok now? You can catch up on all the interview clips from this show, watch UX tutorials, and get more great content from LogRocket. You can check out the LogRocket TikTok today at log.rocket. See you on TikTok.
Hello, and welcome to PodRocket, a web development podcast brought to you by LogRocket. LogRocket provides AI-first session replay and analytics which surround the UX and technical issues impacting user experiences. Start understanding where your users are struggling by trying it for free at logrocket.com. I'm Noel, and today I'm joined by Dev Agrawal, dev advocate and developer, here to talk about building async UIs without the hassle. Welcome, Dev. How's it going?
It's going pretty good. Thank you for having me. I'm excited to talk today.
Of course. Yeah, so your talk is based on this idea that there's some latent complexity around the more responsive and reactive UIs that we seem to be trending towards. Do you think there's a reason that this paradigm has led to challenges in particular? Or why is this a problem that is worth further consideration?
Sure. Yeah. The first thing that we can start with is that the tools that we use today, like React and Angular and Vue, they came out for a use case where we had existing websites or we had server rendered websites or Rails PHP websites. And we wanted to add little bits of interactivity. We wanted to create some widgets or some little island of interactivity within those websites. And those were all synchronous interactions. You click a button, something happens, you animate something, or you change the color from red to blue, something like that. So that's the simple use case and a synchronous use case that a lot of these frameworks were built for. But over time, we started using these frameworks for complete applications. Especially when we got client-side routing, that means we don't have HTML, static HTML anymore served from the server. We have a blank HTML, and then these frameworks do the entire thing. And as soon as that happens, this means that we are now fetching data, we are now fetching additional resources, we are now sending delete and post requests to the server, all within the same framework, which was initially never designed to do that.
Yeah, I think that makes sense. I guess impulse maybe when looking at this is that typically a user action, they click a button, they hit enter, whatever they do, is going to just fire some singular action on the server anyway. And we, I think, do an okay job with a little handler that waits for a response and then something else happens, and it's usually fine-ish. What are some good examples where you see that kind of fall over or become more problematic?
Yeah, of course. Honestly, I can just look into my own professional history and see the kind of apps that I've built to present very good examples of how this goes wrong, because there was time when I didn't know any better. And the spinner hill is one of the big ones, which is that we go to a page and that page requires 5 different pieces of information. And we make 5 of those fetches, and each of them has a separate loading state. So you see loading page, loading this data, loading that data, loading another bit of data here. So you see 5 different loading spinners or maybe more. You have this problem if you go to Twitter today, or actually, I don't remember if they fixed it already, but twitter.com has had this problem for a very long time. Notion has this problem today that you see 3 different loading states pop in. So this is one of them where if you just had one request, it would be much easier. But because a lot of our UI is composed out of a lot of different data sources, and our user doesn't actually care that these are different data sources. They just care about their main content. So we don't necessarily need to expose them to, but here are these 5 different places and 5 different things that we need to fetch before this page is ready.
So I know that my developer brain immediately goes, if there's 3 panels on a page, the middle one is the slowest one for whatever reason. Part of me is there's going to be 3 loading states, and maybe that middle one will be last. But if we make everything wait until that middle one's done loading, is that actually a better experience? Would you advocate that it is better to wait for the longest piece of data to be fetched before rendering?
Yeah, I would say no, it's definitely not better, because there's always, on any certain page, there's always the more important content and the less important content. And we should definitely try to separate that. The problem here is not that we want to combine these things. The problem is more that we shouldn't be forced to handle these things separately. So the example that I bring up in my talk is try catch. Try catch is a way for us to optionally handle errors at whatever point, at whatever level we want to. They don't eliminate error handling for us. They don't do it so that we never have to handle errors. because that's obviously not a good thing. Uh, but they don't force us to handle the error at every point. If you look at some alternate approaches like errors as values, where when you call a function, it gives you back and the error as a value along with the result of the success result, and then you have to handle that at that exact moment before you move on to do something else. Now, there are some reasons to prefer that approach, but overall, that approach does make programming a little more complicated. It makes it a little more verbose. It makes it a little more like you have to do more things to get your basic job done. Whereas try catch, you just keep doing things and then you choose that this is the function where I want to handle all the errors that happen inside. And then I show like an overarching error message for whatever happened here. That's the mentality that we need to take into building async UIs for our users. It's that we want to encapsulate a piece of UI and say that anything async happens here, we want to handle that separately instead of being forced to do it for based on data.
I see. So do you think that this is fundamentally a component architecture problem then? Is this a problem with the frameworks, maybe inadvertently or intentionally pointing developers down a path that leads them to this kind of trap?
I wouldn't say it's a component architecture problem. I would say it's more of a state management problem. The problem is that the way we do state management is synchronous. We set a state and we immediately see the results. And I say problem as in it's actually a good thing that we have synchronous state management. But yes, the synchronous nature of our state is what causes this issue. Because let's say I kick off an async process. Let's say I have 3 tabs on my page. I click on tab 2, it's loading some content. By the time that data gets back, because there's some time that's been passed, maybe that data is not needed anymore. Maybe the user has already clicked on to tab 3. And in that case, I don't want to show the results of tab 2. I just want to discard that because if synchronously we have moved on to tab 3 at the exact point that the user clicked on it. The results are still waiting. And as soon as we get back, we need to realize that, okay, the world has moved on. We cannot show results anymore. We have to wait for something else now.
I think there are setups where in those cases can be particularly problematic, right? If your component is set up where the contents of the tabs are a shared component, and then you click on 2 and then click on 3, and 3 actually comes back first, and then 2 comes back and overrides the data you're looking at, suddenly like something's mismatched. And I think we've hit those. Do you think that there is a better way than just leaving this in developers' hands? Oh, you just like do it right. Be sure to watch for further navigation to cancel things. Is there a particular solution that you think is elegant?
Yeah, definitely. And I think the React team did a pretty good job at coming up with an elegant solution to these problems. And that was what my talk, Building Asynchronous UIs Without the Hassle, was all about.
So, what is the mental shift that one has to make to start thinking about asynchronous state in a more productive way?
Yeah, great question. And it's something that I hinted at earlier, try catch, basically. But except try catch is something that you wrap over your function calls, your expressions. What React and Solid give us is a component boundary called suspense. And that's something you wrap a bunch of your UI or your components with. And the kind of second side of the coin is that your components can declare asynchronous data sources. So, for example, you have basically a new hook or a new way to consume a promise within a component. And this tells React that this component now depends on some data or some asynchronous source. So when you go to render, that component can suspend because React will try to render that component and it'll realize that the promise that we depend on is not resolved yet. And at that point, React will, and the suspense boundaries, which are try-catch boundaries, they catch the suspension and they show a fallback. So if there's any component that's a children of this that you passed into the suspense boundary that at any point suspends or depends on some asynchronous source that's not ready, you're always going to show the fallback. And the contents inside the suspense boundary are only going to be shown once everything is ready. So you don't have intermediate states, you don't have UI tearing, you just have the final consistent state of your UI. Again, try catch. Or maybe you can also think of it like async await, where you mark a function as async, but then you can just await a promise inside that function and you just get the final value of the promise. And until that's ready, you don't execute anything below that.
Gotcha. How does this kind of play into this problem I talked about briefly before of maybe there's some long pull that happens to be like nested super deep and it's not even that important, but we pull this data point in. Is there a way to isolate this like one little piece, or does that just come naturally from this architecture?
Yeah. So it's actually really easy. You just wrap it with another suspense boundary. So you render everything under suspense, but when you reach another suspense boundary, it now handles its children separately. The suspense boundary that's higher up, the parent, it doesn't need to wait for all its children. It only needs to wait for anything that's between it and its children's suspense. Let's say I have my homepage, or the way that I showed this in my talk is I have a session details page for, let's say, a conference. So you go to the session details page. It shows the details of the session, the description, the title. It shows the speaker details, the name and a bio, and then it shows a feedback widget. Now, the feedback widget takes a little longer to respond because it needs to look at the attendee role and it needs to fetch its own data. So the feedback widget was wrapped in its own suspense boundary. So the first time you go to the session details page, you'll see the loading session details. Then you see all the session details and you see loading feedback widget. And at some point you see the feedback widget itself. So again, you can nest suspense boundaries to do this, separate this, show this first and show this later. Don't wait on this. But the big kind of difference here is that you're making your decision based on UI, not based on data. So you might still be thinking in terms of, okay, I have this piece of data that takes a while to load, and that's what I want to wait for. But suspense forces you to think more in terms of UI. So even if you have a piece of data that takes a while to load, if that's like in the important part of your UI, you are going to hold that UI first. So you need to bring back some of the, okay, this piece of data is being loaded in this component. I need to make sure this component is wrapped with its own suspense boundary and it doesn't block the entire page.
Nice. Can we circle this back to our example before, maybe with a couple different tabs, right, that are being loaded? How does this help mitigate this problem of switching to a tab while a prior tab's in the midst of being retrieved?
Yeah. So this helps there by when you declare a component to depend on its promise using whatever primitives React and Solid give you, as soon as you switch from tab 2 to tab 3, you start rendering that component again, but this time with tab 3 instead of tab 2. This automatically tells React. Now, because React is the one that's handling these promises under the hood, React will automatically discard this tab 2 for us because it knows that we have switched to tab 3. That's the one that we are waiting on. Tab 2 is no longer needed. The way React manages it internally is they basically rewrote their runtime into something called fibers. It's a whole technical deep dive in itself. I'm not going to do deep dive into that much. But the point is basically because React is handling these promises, it knows what the current state is. It can discard those promises by itself.
Nice. This feels like one of those classic instances where a common problem that devs were trying to solve, and the thing that felt the most straightforward and intuitive was often problematic or wrong in certain cases. So now we have a managed way that's better. I think the other side of this coin is it can be tricky to bring this into the tool set that devs are. It's like another thing, maybe is the cleanest way to put this, that devs have to be cognizant of when developing in one of these frameworks. Do you think that the suspense boundary system is intuitive enough or like first class enough to be easily like understood, especially for new React developers or Svelte developers or Solid developers rather? Sorry.
Yeah, that's a great question. This is one place where React and Solid have a very different kind of viewpoint, or at least like a reception from the ecosystem, because React, obviously, it took a long time to come out with its suspense model. It took all the way to React 19 to do that. They've been building it for a very long time. They've been talking about it, but it took a very long time to finalize and present it to the ecosystem. Solid had suspense and suspense-based data fetching since it released 1.0. Solid's entire ecosystem grew up, so to say, with this model. Even if now there's still the problem is that a lot of Solid developers come from React and they're not familiar with this model, so they just default or autopilot back to the classic way of data fetching and handling these states. But at least the ecosystem around Solid is like very mature in terms of adopting suspense for its patterns. React has the opposite problem where React developers have spent a very long time handling all these cases by ourselves, that it's almost become natural to us. when you do something complicated for a very long time, even that complicated thing becomes a second sense for you. You get very good at handling these edge cases all by yourself. That doesn't mean they shouldn't be managed for us by our tools. It just means that we now have to unlearn a lot of things that we have been doing for the past decade almost. And the same applies for the ecosystem. A lot of the ecosystem, like Tanstack Query is the prime example, it handled some of these cases on its own. So now they have to come up with alternative options. They have to come up with new APIs that better take advantage of these built-in APIs within React.
Do you think that like Solid's approach is, I don't know, I don't want to say better because that feels overly simplistic, like having it kind of more ingrained. Do you think that makes this less of a hurdle?
Like less of a hurdle in terms of adoption for developers?
Adoption and kind of understanding, or just like the developer that's spending all their time in Solid versus React. Do you think it's like a lower passive cognitive load for them to have to worry about this?
The first one I already mentioned, which is that it has had suspense-based data fetching since it's released, which means the mindshare, the ecosystem has already adopted it. The second one is that the React suspense model has a lot of issues, a lot of pitfalls that if you try to use the React APIs directly, first of all, they're not fully documented yet for good reasons, but they're not fully documented. And the second is that there's a lot of little edge cases that you're going to cut yourself on. And React knows this, which is why they recommend us to use a framework like Next.js or like Remix. They don't want us to use suspense with data fetching directly with React. They want us to use a framework because the framework addresses some of the pitfalls, some of the problems with React's model. And not only that, people who are building with different frameworks are going to have different ideas on how to do data fetching. They're not always going to transfer over. The way Next.js, I would fetch data in Next.js would look different from React Router. It would look different from Tanstack Start and so on, right? So that's going to offer some friction there. Those problems don't exist in Solid. With Solid, you have a much more native and natural way to do data fetching, and everything around the ecosystem just builds on top of that. So it removes a lot of that friction from that point.
Do you think that decision from the React team to put this more in the realm of the framework, right? This interface should be a thing that the framework is using. Do you think that will lead to kind of problems with adoption? I'm thinking of like people that have large existing React code bases that aren't using one of these already. Is it enough of a barrier where for them, they probably won't ever make the switch until they decide to do like a pretty large overhaul or switch to using Next or something of that nature?
Yeah, it's yes and no. The React team is really good at maintaining like backwards compatible changes and offering like easy migration paths. So like any existing code bases, if they can get over like some very small hurdles and move over to React 19, at any point they can start taking advantage of these models. So it's not like they need a pretty big overhaul to do it because they can just upgrade to the new version, have everything work backwards compatible, and then incrementally migrate. But yeah, the framework problem does get in the way because if they're not already using a framework that supports suspense data fetching, they either have to move to one or they have to bring in a library. Like now, the good thing is Tanstack Query is probably the big one that's being used out there, and they do have a new API that takes advantage of suspense. So anyone who's using React Query, Tanstack Query, they probably have a much easier time moving over to the suspense-based models. There's still a little additional overhead. For example, if in a component you have two use query hooks right next to each other, they're both going to fetch at the same time normally. But if you change them to use suspense query, which is Tanstack Query's way of exposing a suspense-based data fetch, they're going to waterfall, which means you're going to start fetching the first one and it's going to stop executing that component. And only once it resolves, it's going to go to the second one. So you're going to run into, again, small little edge cases like that because just because Tanstack Query is not a complete framework, it's just a library that gives you access to the underlying APIs, but you still have to do a lot of manual work to make them fully work and efficient for you.
Yeah, that feels like another case too, where developers that are like, they find a tutorial online, they don't understand like what this function call is actually doing or like why it would be good to parallelize this data fetch. It just seems so far down the rabbit hole of what you should actually be needing to page in. That kind of, I guess that leads me to one of my final questions here is this is a tricky problem in general that we've been facing on like back end, front end, like just asynchronous things happening in parallel and like trying to figure out how to handle those. I think they are a problem space that is, I don't know if they're counter to a lot of the simplicity I think that software development in general has. It's okay. Now I have to worry about time and state and race conditions and all of this stuff. So do you think this will always be kind of a tricky problem from the front end's perspective? Do you think what we have here is about as elegant as this can get, or do you think this will continue to get easier to wrangle over time?
Yeah, there's definitely that sentiment that asynchrony is just a difficult problem. And this is, you can see this on front end, you can see this in back end, you see this everywhere, just because there's that concept of time. So yeah, doing anything async is always going to be a challenging problem. All we can hope is to come up with patterns that help us cope with that. And one way to do that is to find specific use cases. For example, suspense and transitions, which is like the second half of the coin. They help us with very specific use cases within the way we fetch data and the way we program our UIs. They don't encapsulate all the things that we can do asynchronously. They pick their certain lane that these are the use cases that we want to solve, and they give us the best patterns to do that. I do think I never want to say that this is the best that we can come up with and we are never going to come up with anything better, because that just stops innovation right there. But yeah, this is definitely the best that we've had so far. And that's mostly because, again, they decided to pick specific use cases that they want to address and not the entire world of asynchronous use cases.
Yeah. I think that is an insightful kind of observation to make because this is such a specific repeated problem. This abstraction is a pretty meaningful one to kind of mitigate. And okay, we can actually handle most of these cases for you front end developers. Is there anything else you want to touch on that's in the meat of the talk?
I think we could talk a little bit more about transitions. We talked about like suspense and loading fallbacks.
You mentioned transitions there and how like these are tuned to handle that problem, or that they're we're trying to solve that problem specifically here and are tuned for it. Can you explain a little bit more about what the transition problem is that we're trying to solve?
Sure, yeah. So we can go back to our tabs example where we have tab 1, tab 2, tab 3. You click on tab 2, and the first thing that we already address is that when we click on tab 3, we want to discard the results of tab 2. Okay, we're fine there. But now let's say that we have a suspense boundary around the contents of the tab. And every time we are fetching some data for those contents, we show the fallback. And once the data is there, we show the contents itself. You click on tab 2, you see the fallback because we don't have the data for tab 2 yet. And then we see the results. We click on tab 3, we see the fallback again, we see the loading state, and then we see the content. So in some cases, this is probably fine. But now, at the first time you're rendering the page, like the first time the user navigates there, there's no data to show. So it's fine to show the fallback. But when you're clicking from tab 1 to tab 2, you might want to just keep the tab 1 results there until the tab 2 results show up, because it's jarring to just make all the content disappear. So transitions give us a way to, like, almost in a way, like opt out of suspense programmatically. So when you say that switch to tab 2, you can do it within a transition and like literally wrap that function in a function called start transition. And that tells React that, hey, if setting this state or if switching to this state causes any suspense fallbacks to show up, don't make the fallback show up. Just keep the current content there and then switch to the new UI once it's ready. So it's a way to keep the current UI there and then do things in the background and then switch to the new UI once it's available. They also give you a way to, like, a Boolean flag to tell you if there is a transition that's going on in the background. So you can show like a loading indicator somewhere. So like on the current page, you can show some feedback that, hey, we're doing some work in the background, and then you switch to the new UI. And so that's the big important highlight feature of transitions, that you can switch to a new page, you can refetch some data in the background. And then the other thing is that you can combine a bunch of async operations into one. So let's say I make a post request and then I have to refetch some of my data to get back the current UI. So all of that can be combined into a single transition, which means you get a single pending indicator for all of those things. And then once everything settles, you get the final resulting state.
Nice. That's pretty cool. How, in this theoretical tabs example, is there any kind of potential trap that one could fall into here? Say a user clicks a tab and then they're waiting for it to load and they click another tab in the interim. Are there guardrails in place to help handle that case, or is that still largely up to the developer. Say they're on like tab 1 and they like click tab 2 and the transition begins. So they're still looking at tab 1, but the tab 2 loading transition's begun. And then in the interim, they click like tab 3 before the tab 2 transition's completed. Is there any kind of built-in utility to help with that problem?
Yeah, discarding the intermediate states, that still gets handled by React. If you click on tab 3 while tab 2 is not ready, you're not going to see the results of tab 2. Then we talked about transitions automatically merging into each other. When you click from tab 2 to tab 3, you're still going to have the pending indicator that, hey, we're doing something in the background. We're going to switch to the new UI once it's available. Other than that, I think the biggest pitfall that developers might run into is just to not provide that feedback to the users that, hey, there's something in the background going on here, which means if you click on tab 2, you actually don't give any feedback to the user. So the user might think that the app is just stuck. This is like one problem that you can get into because, again, previously we were forced to handle all the intermediate states. But when the underlying model makes that optional, sometimes we might just forget to do that. So we need to make sure that provide the user feedback that, hey, we are doing something in the background. We are switching to a different state here. We are fetching some data for you. And so that they don't think that the app is stuck.
That's as good a point as any for us to transition into some of our quick questions here. And I want to wrap up with one that's like on quick pieces of advice similar to that to like help developers handle this. But just to start with, what's one new feature in React or Solid that feels like magic when it comes to concurrency?
Yeah, the feature I would say that makes it feel like magic the most is the non-nullability. And the way I explain is that when you fetch some data and you get the results in a piece of state, usually you would have that that data can be undefined. So if you fetch a user, the piece of state can be a user or undefined. We don't have that anymore. We just have user. So we can just show that data. We don't have to handle undefined or null cases anymore.
Do you think that's the single most frustrating part of like handling asynchronous processes?
I think it's very close to top of the list because just imagine how many users are not found or still loading, or changing the prop types of your component to accept an undefined just because you're now fetching something from high up above. So it led to a lot of problems, like a lot of additional work that we had to put in. But now our components don't need to know if they're getting data from a query or not. We just pass them the data that they need. Like it was always there.
Cool. Then circling back to what you were saying before, is there any kind of particular advice you would give to a developer new to concurrency?
Definitely test your app under extreme conditions. Add artificial latencies, click a bunch of buttons like very fast, each click like 20 different buttons, one after the other. Do the most extreme stuff that you can to your app under the extreme conditions, because that's how you will find those bugs. And if you don't find those concurrency bugs, I promise you, your users will. And they won't always report back to you.
Yeah, I agree. This isn't was one of our planned questions, but are there any tools that you find particularly useful to simulate like heavy load, these extreme conditions?
Yeah, learn about the network tab in the Chrome DevTools. At the very least, there's a throttling section there where you can go back to 4G, 3G, things like that, or just like hop into your code and add some like artificial set timeouts.
Nice, perfect, cool. I think that's all I had. Thank you for coming online and chatting with me, Dev. It's been a pleasure.
Thank you for having me on.